Okay, so the computer crashed during recording that last video, but we had our angle just about figured out, and our angle was, we were using this formula, and I'm looking for the angle, so I'm doing this, and the opposite side was between the, hang on, sine to the -1. My opposite side was 15.6. And my hypotenuse we figured out was 32.227. And if I take those two, 15.6, I divide it by 32.227, and I take the inverse sine, I get 28.95 degrees, which rounds to approximately 29 degrees. So out of our choices, 29 degrees shows up here and here, which knocks out these two. And for our 32.227, none of these quite match, but two of them are close, and two of them are pretty far away. So given these choices of bad, good, bad, bad, good, bad, and good, good, this is our clear winner. We're going to choose A. So it would be even better if this, instead of saying 32.3, said 32.2, but what are we going to do? Pick the best answer available. So we'll pick A for that. On to our next two questions. And I realize now that you can't actually see the start of that one. Okay. Here we have the front of a tent has the shape of an isosceles triangle. I'm going to give little marks here to show it's isosceles, with equal sides that are, that's a typo, 150 centimeters long. The measure of the big angle at the peak, so this angle right here, is 110 degrees. What is the maximum headroom height inside the tent to the nearest centimeter? So they're asking us for what is the height of this triangle. So if I draw this triangle, hang on here, I think I might be able to draw a isosceles triangle, can I? You're probably all able to see this right now and I can't. Maybe I can do this. So if I draw an, oh hell, I don't know what's going on there, but sure. An isosceles triangle, and I want to find the height. Maybe we'll just look at the inside of this tent or something. So the inside of the tent here is this one. This is the line we're looking for. This here, from here to here, is 150. We're just ignoring this outside one. I didn't know I was going to draw two triangles on me. So with an isosceles triangle, if these sides are the same, I know that I can treat them as two halves that are both made out of right triangles. So this angle here is 110, which means that each half angle, so inside this little bit right here, is 110 over 2. And half of 110 is obviously going to be 55. So the big angle there, from here all the way to here, that was 110 degrees, and half of it is 55. So I know this angle is 55, I know this side is 150, and I'm looking for the height. So for this angle, this side is, this side here is my hypotenuse, and this side here is my adjacent. The height will be my adjacent, and I'm solving for that. With hypotenuse and adjacent, that's going to be cos. I'm looking for the adjacent side, that's what I'm searching for. So I'm going to solve for A. The hypotenuse was 150 centimeters, times the cosine of my little angle there was 55. And if I take the cosine of 55, that's 0.57. And if I multiply that by 150, I get 86 degrees. Not 86 degrees, Cosine gets rid of this sign here. Centimeters is left. Centimeters. 86 centimeters is my adjacent side. So this here is 86 centimeters, which is going to be choice C. Next, a girl guide observed a monument directly to the east, presumably of herself. She measured the angle of elevation to the top of the monument at 50 degrees. So we've got a triangle, which I'm going to draw a right triangle. It's to the east. Can I make this flip around the other way? I can't. Okay, I can't make it face to the, make it be to her east. Northeast. Sorry about that. I don't know how to flip this around the other way. So we'll just pretend like that's the east. Sure. The angle of elevation is 50 degrees. So in here, this is 50 degrees. The height of the monument is 50 meters. And she walked due west for 50 more meters. So again, we're going to pretend like our compass is all backwards, or we're looking from the wrong side, for 50 more meters. And she wants the new angle of elevation now. So for her new angle of elevation, it's going to be longer, but up to the same height. So here's her second spot. So we want to know what's this angle. We know it's going to be less than 50 degrees, right? That's a sharper, that's more acute. But we want to find out what it is. So first we need to figure out something else. If she is, so she observed the monument directly to the east, she measured the angle of elevation as 50 degrees, the height of the monument is 50 meters, she walked due west for 50 more meters. Okay, so I know from here to here, that's another 50 meters. We don't know how far this was. Now we're going to try to figure this out. So first we need to figure out that, right? If we want to figure out this angle, we're going to need some piece of information. We know this side for sure for both of them. It's the same monument in both cases. And we're going to need to figure out how far she was away in the first place. So at the start, get this to scroll up here. At the start, we're looking for the adjacent side. And we are given, so here's where she is, and we are given her opposite side. So we have opposite and adjacent. So that tells us we're using the tan function. So we are looking for the adjacent side. We're going to have to solve for it. I multiplied both sides by a, so that I could cancel these guys out, and then I divided both sides by tan theta so I could cancel this one out, and now I have my adjacent side, which is this bit right here, is equal to my opposite side, which is 50 meters, over the tangent of my 50 degree initial angle of elevation. So if I take 50 meters and I divide it by the tangent of 50, which is 1.19, so that's, oops, 50 meters over 1.19, etc. Keep all those decimals. I get 41.95, etc. meters. That's how far we were here. From here to here was 41.95 meters. Now I'm going to change colors because I think it's confusing if I'm using the same color here. So from here to here was 50 meters, and we're looking for this angle. So now we have the distance from here, the monument, all the way to her new spot. So this entire base, which I could highlight here, this entire base is 41.95 plus 50. So this entire base here is 91.95 meters. That's from here to here. That is my adjacent side for my missing thing here. I'm going to use tan again. I'm going to solve for the angle is equal to the inverse tan of opposite over adjacent, which is the inverse tan of my opposite side is 50 meters, and my adjacent side is now 91.95 meters. So if I take 50 divided by 91.95, and then I take the inverse tan of that, I should get 28.53, etc. degrees. Meters and meters will have cancelled out, and inverse tan puts me back into degree territory there. So 28.53 degrees, and this says to the nearest tenth of a degree, so I would type in there 28.5. I can't type degrees, but if I did, I would. So what we did here was we took our first triangle and we solved for the adjacent side, which was 41.95. And then we took our second triangle, which is this bigger one, including all that, and we know the adjacent side, 50 plus 41.95 is 91.95. We know the opposite, which is the height of the monument, is 50. And with opposite and adjacent, we can solve for the angle using inverse tan. Okay, I'll stop this one, go on to our next.